Data types. So first of all, let's take a look at what data types are. So first, there's two categories of data types. You have the ones that are fixed storage size in memory, which basically means that the memory that your program uses, it already knows what type of data you're storing there, and it knows what's the space that it needs to allocate in memory. Okay, and some of these types are int, uint, float, double, and bool. By the way, int stands for integer, which is a whole number. Uint stands for unsigned integer. More to come in the next slides. And then you have the flexible size in memory. Now, flexible size in memory means that the memory does not know what's the size of this object or data that's going to be stored. So what's going to happen with that is going to have to allocate more space because it doesn't know if it needs a little chunk or a bigger chunk. Okay, and if the chunk is way too big, then it's going to have to chunk it in multiple places in memory. So obviously you can tell it's going to be a lot harder to handle for the memory, right? Some of these examples of data types are var for variable, string, which is a text, images, you guys all know what images are, objects, and more to come. Okay, so why do we have multiple data types? You know, like we can just use var, right? You know, like in a program, we can just write var for variable and just give it a name and be done, right? And some programs actually do that, such as JavaScript, for those of you that already know how to program. So the reason why Swift uses data types is for many reasons, but these three reasons are the major ones. One, it's for correctness. By correctness, we need that not all operation makes sense with certain data types. And that helps the program find errors before you run the program. So it will avoid your program to crash. Why? Let's say in this example, you cannot multiply two strings of text. It makes no sense if you do hello world, the text hello world, and you multiply that by the text John Smith. It just makes no sense. You cannot multiply two texts. What exactly are you trying to do with that? And in JavaScript, the JavaScript would let you do that, and obviously the program would give you an undefined value, or the result would not be what you expect it to be. So that's the first reason. Another reason is performance. It's a lot easier to handle memory space, in the sense that if you know you're using numbers and those numbers are of a certain size, in memory they're going to take less space, and it's going to be a lot faster. So that's performance. So if you know what type you're dealing with, then your program will run faster. And then another reason why we use multiple data types is for documentation. By documentation, we mean that programs are easier to read for us humans, in the sense that if we say, okay, this data is a whole number, we know that during the whole code, as we read the code, we know that this variable would be used for a number and not for an image or something else. Okay, so it's easier for us to read the code. Moving on. The first type that I was referring to was integers, or int. So integers are probably the easiest ones to work with. They store whole numbers. And since integers have a specific size in memory, they have a maximum and a minimum value they cannot go over. Let's say in memory, if it uses 8 spots, you can only make X amount of values. So you have to know that. And there's different types of integers to deal with different size of value. Now, if you're doing like you're counting the number of students in a classroom, the numbers are going to be pretty small, right? It's never going to go over 100. Now, if you're counting the number of cells in a human body, it's going to be in trillions. So it's not going to be the same size. So you're going to need a lot more room in memory. Okay? And so these are examples of the different types of integers that are within Swift. It provides signed and unsigned integers. So let me explain you what signed and unsigned are. But first of all, I want to tell you that it's in 8, 16, 32, and 64-bit forms. Now, those of you that don't know what bits are, it's basically a representation of a 0 over 1. And 8, 16, 32, and 64 are the size of the chunk. So a chunk of 8 would be 8 bit in a row. Okay, so 8 digits in a row. And these digits cannot be 0 or 1. So 64-bit would be 64 zeros or ones in a row. Okay? So signed integers are whole numbers that could be either positive or negative, okay, when they are signed. So they do have a sign, okay? And if you use max 8, as you can see in the example, var max 8, it's an int 8, so it has 8 bits. The values go from negative 127 to 127. Why? Because if you think about it, 0 and 1 are two values, so you're in binary. Binary means you can only use two numbers, 0 or 1. So when you have a string or a sequence or a chunk of 8 digits, you can only make 2 to the 8 combinations, okay? 2 to the power 8, which is 256 combinations. So since half is positive and half is negative, 256 divided by 2, you're going to have negative 127 all the way to 127, including 0. That's the reason behind. And it's the same logic for the max 16 here, which is an integer of 16, which basically are going to store numbers from negative 32,767 to 32,767. Then 32 and 64, I'm not going to read those values, but as you can see, when you use an int 64, the maximum value can go really high, right? And that's probably what you want to use if you were using organic cells. All right, and then the unsigned integers, obviously, as you can see in the example, the unsigned ones can go only from 0, so there's no negative number, but they can go to way higher numbers. As you can see, it's basically twice as big as the signed ones. Boolean types. Okay, so the type Boolean, Swift has a basic Boolean type. It's called bool, which it can store only two values, true or false. In math, Boole is the person that actually invented that. It's usually sometimes when you ask a question that you can answer by yes or no, or true or false, this is usually a Boolean answer. Okay, so for example, planet Earth is blue, and we put equal true because yes, it is true. The planet Earth is blue. Now, planet Mars is yellow. That's false. So we put equal to false. Then var planet Jupiter is blue. Is blue. We force it to be a bool, saying that yes, the value can only be true or false. Okay, so in the first one we set it to true. In the first two examples, you can see that we did not say bool, and what's going on is that the system or the compiler, and I'm going to explain you in the near slides what a compiler is. But the system, the program, is understanding that we are using Boolean here. That can only be true or false. Now, nil type, question mark, and exclamation point symbols. So, Swift can represent a value that has no value, right? Sometimes you need a value that has no value. It's called nil. Okay, and here is an example, var classroom student count. So we're counting the number of students, and we put it's an integer with an exclamation point, which means that it has no value yet. So if we print the value of this classroom student count, it's going to be nil at first. Why? Because we did not set any values. Okay, so we did not say is equal to 10 or is equal to 20. So automatically the value is going to be nil because we did not write any values there. So let's now say what the compiler is, because the compiler is the one that says that if it hasn't been set, then it's nil. So the compiler, it's the computer program that will transform the source code written, with basically whatever we're writing in the Xcode language, in the language Swift, and it's transforming this into a language the computer can understand, and that language is binary or chunks of binary string. For example, 010110000, this is a chunk of binary string. Now, whenever you write something like this, classroom student count int, this is only one instruction that you write. It's only, here we're actually writing two lines. But when these two lines are translated, they're translated into chunks of 0 and 1s. Now, you probably will think, oh, it's only two instructions, so it might be two chunks of 0s and 1s. Absolutely not. These two lines are actually probably hundreds, if not thousands, of binary string for the computer to understand what to do there. But don't worry about it. Nowadays, computers, especially iPhones, can handle probably almost billions of these chunks in a second. Okay, so this is the clock or the frequency. You guys have already heard about frequencies of a CPU, 1.2 megahertz, 3 gigahertz, and so on. These are the number of transactions per second, okay, or instructions per second. And final slide here, the question mark symbol at the end of a type. it's called optional, which means the variable's value is optional. Nil is nil if not set. So if you do not set the value of, let's say, survey answer, you do not have any value yet. If you put a question mark at the end, it will automatically set it to nil. Okay? So as you can see also, the variable lottery winner name string with a question mark is equal to nil. Here we're forcing it to be nil. Okay? And if you print at the end, the last example, you see that the lottery winner name, we put it equal to Jennifer. So if we print it, it will print Jennifer now and not nil anymore. Okay? All right. Thanks for watching. See you guys in the next lecture.